course, if I'm talking about $1 billion project, I probably should be a little bit careful. I mean, biasing $1 billion project towards short-term liquid term stuff actually does a disservice to shareholders because you are potentially foregoing projects that's going to make you a lot of money, but you just have to wait a little for them. Then you go with our other criteria. But in a decentralized capital budgeting environment, you let the small projects take care of themselves that way. All right, we got about 20 minutes. Let's take care of one more issue that is kind of a thorn in our backs. What happens if the cash flows are non-conventional, which means at least one of the future cash flows are negative? If let me reduce thing to 3, and I'm, for example, in this case, by the way, uh, that's 3, but I don't have any black ones, so that project does not pay itself back. So if I ask you payback period, your answer should be never, if that happens. Let me make this project cost 50,000, and but there is a $20,000 delayed cost in a sense. This sort of stuff could happen in projects where it costs you money to actually wrap up everything. Okay. Uh, in this scenario, there is no mathematical guarantee that there is a unique, real solution to the equation that defines IRR. In fact, the rule of thumb is number of solutions is equal to number of sign changes. I go from negative to positive, then the positive to negative. So you should expect 2 solutions. And let's see, in fact, there are 2 solutions. In this case, IRR actually gave me nothing. Okay. Let me, there's a second argument to the IRR, which is a initial guess. Oh, let's do this. This is my NPV, right? Data, what if analysis, goal seek. Make my NPV 0 by changing IRR, by changing cost of capital. Turns out it can't even find a solution. Cancel. Let's make this number. I still can't find one. But either way, even if it found one number, there is no guarantee that that number is unique. So if either a solution doesn't exist or there are multiple solutions, the entire concept of internal rate of return is mathematically ill-defined. If there's no solution, there is no internal rate of return. If there are 2 or more solutions, which one is the internal one? So what we're going to do, but even in those cases, the people who would be interested in a number like IRR, people who wants a rate of return, they still want something like that. So to appease those people, you know, just like life in finance too, necessity is mother of all inventions. We're going to come up with a number like that. We're going to kind of cheat the system, or the so-called, any Star Trek fans here? Just look up Kobayashi Maru. Okay, you'll know what I mean. Kobayashi Maru is that training exercise in Star Trek Academy, where they put you in situations where there is no possibility of winning. You know you're going to lose the battle. You don't necessarily know, but the way the simulation is set up, no matter what you do, you're going to lose the battle. The entire point of the test is to see how you respond. Um, so this is the Kobayashi model. And there was only one person who ever beat Kobayashi model. That was Captain Kirk. You know how he beat it? He cheated and changed the simulation parameters. So he made it winnable, potentially winnable. So we're going to do a Kobayashi Maru. We're going to pull a Kirk here. We're going to cheat. We're going to ask the following question. What if I modified the cash flows so that they became conventional? Then I can calculate an IRR for them. In fact, we call that the modified internal rate of return. Your book talks about 3 different ways of doing it. Don't particularly care for 2 of them. I'm going to show you only how to calculate one of them, and you won't even be responsible for the other ones. There is even a function called MIRR in Excel, but it doesn't do what you want. What we're going to do, we're going to recognize that future negative cash flows are essentially delayed costs. So the way we're going to modify the cash flow, if there's a future negative cash flow, I'm going to modify that to be 0. By definition, none of the cash flows are negative except the period 0. But to compensate for that, I'm going to take the present value of that, add it back to the original cost. And we're going to easily do that. So let's calculate modified cash flows, not VASH. That's a character in Star Trek as well. Star Trek: The Next Generation. I'm going to first let me do a format on these things first. And let's make him black, white, $, bold. And I'm going to copy and paste the format of this. I'm going to modify the color of this too. Let's make that purple. All right. Now, let's modify the future cash flows first. First things first, if the year is greater than the life of the project, let's make sure that we get a 0. That has nothing to do with modification to begin with. But otherwise, if the cash flow is negative, make that 0. Otherwise, leave it as it is. As you can see, it's zeroed out the third one. Just to show myself which ones is zeroed out, I'm going to do a conditional format on that. This is kind of being anal about it, make sure that the right thing is modified. So mathematically speaking, it has no value, but functionally speaking, it does. New rule, I'm going to do format only cells that contain Uh,